Bismillahirrahmanirrahim. Today is a lecture number 9, and today's topic is Deep Learning Framework. Myself, I am Dr. Muhammad Farooq. So let us begin the topic. First, we shall see this is the outline of this today's lecture. Introduction, why use deep learning frameworks, choosing the right framework, summary. Okay, this is the outline of the today's chapter. So what are the objectives of deep learning framework? Simplifying model development, optimizing performance. So let us see what is the simplifying modeling development. It provides high-level API, that is application programming interface, for easy model building, allow rapid prototyping with pre-built layers and modules, support both beginners friendly keras and external implementation. Optimizing performance, utilize GPU and TPU acceleration for the faster training, enable different parallel computing and distributed training for large data sets, provide automatic differentiation for the back propagation. Now next topic is what uh, third point. This is the third objective: enhancing scalability. It supports, which means support cloud-based AI solution. Example: TensorFlow on Google Cloud, MaxNet on AWS. AWS means Amazon um, Web Services, enable development in modern mobile age and embedded devices. Example: TensorFlow like Onyx, facilitate distributed computing for handling big data, supporting model interoperability and debugging, allow real-time monitoring and visualization. Example: TensorBoard for the this one, provide tools for model explainability, support dynamic computation graphs. So these are the objectives of deep learning framework. Now definition of the deep learning framework. Deep learning frameworks are software libraries or platform that provide the tools and utilities needed to develop, train, and develop and deploy deep learning models. These frameworks simplify the process of building neural networks by offering pre-built components such as layers, optimization, algorithms, and utilities for handling data so that developers and researchers can focus on designing and fine-tuning models than building everything from scratch. Okay, this is the definition of the deep learning framework. Okay, now some popular deep learning frameworks includes TensorFlow, PyTorch, and Keras. Okay, so what? Let us see that TensorFlow. What it is: an open source framework developed by Google for numerical models, especially deep neural networks. PyTorch developed by the Facebook AI Research Lab. But PyTorch is known for its flexibility and dynamic computational graph. It is popular in research and academia. Keras, originally a separate library, Keras is now integrated. Some popular deep learning frameworks include MaxNet, Tenol, KEF. Okay, these are the some popular deep learning frameworks, right? So now let us see the introduction part to deep learning frameworks. Deep learning frameworks are specialized software libraries designed to facilitate the development and deployment of the deep learning models. These provide a set of high-level tools, APIs, and application programming interface, and abstractions that help researchers, data scientists, and developers implement complex neural networks without needing to code everything from scratch. Deep learning models, especially neural networks, often involves large number of the competitions and optimization, and these frameworks make it easier to handle the task efficiently. Now, these are the key components of the deep learning frameworks. Number one, pre-built layers and models. Frameworks offer pre-constructed neural networks like conventional dense or recurrent layers and other utilities like activation functions, loss functions, and optimizers. Second, automatic differentiations. Frameworks provide tools that automatically compute gradients for back propagation, which is crucial for training neural networks using gradients based optimization methods. Optimized computation. Many deep learning frameworks supports acceleration like GPUs and TPUs, allowing for faster computational training the large data sets in the less time. Now, same key points. Fourth point, data handling and pre-processing. These frameworks typically include functions for loading, pre-processing, and augmenting datasets, which can be essential for tasks like image classification, natural language processing, or time series prediction, model training, and evaluation. What does it mean? Deep learning frameworks offer built-in tools for model training using the algorithms like stochastic gradient descent and evaluating performance through metrics like accuracy, precision, and recall. Deployment. Once the model is trained, deep learning frameworks also provide utilities for exporting and developing models into production environment like mobile apps or cloud-based services. Okay. Now, why use this is the why use this is the question? Why use deep learning frameworks? Using the deep learning frameworks offers several advantages, making the process of building, training, and deploying deep learning models much easier, more efficient, and scalable. Here are some key reasons to use a deep learning framework. Simplifies development, abstract complex operations. Deep learning frameworks provide high level abstractions of complex mathematical operations involved in building neural networks like matrix multiplication, backpropagation, and gradients descent. This reduces the need for manually coding and understanding every detail of this process. They come with pre-built layers, optimizer, acquisition functions, and loss functions, which allow to focus on the model and architecture rather than reviewing the lab wheel. Okay, now this is the why use the second point. Faster experimentation means what? Rapid prototyping. Deep learning frameworks enable quick prototyping of the models with built-in function. Developers can experiment with different network architectures and hypermeters faster, allowing them to find the optimal design more quickly. Flexibility. Many frameworks like PyTorch support dynamic computations, graphs, eager execution, which allows to more flexible and easier debugging compared to static graphs. This is helpful for research and experimentation. Third point, scalability and efficiency. GPU and TPU support deep learning tasks are computationally intensive. Frameworks like TensorFlow and PyTorch are optimized to leverage hardware accelerators like GPUs and TPUs, significantly speeding up the training process for large datasets and complex models. Distributed training is for very large models or datasets. Frameworks can distribute the training process across multiple devices or machine, improving performance and scalability. Automatic differentiation back propagation. One of the key challenges in the training and neural networks, computing the gradients needed for the optimization. Deep learning frameworks handles this automatically through automatic differentiation. This allows you to focus on model architecture without worrying about the math behind the propagation. Community and the ecosystem support. Extensive libraries and resources. Popular frameworks like TensorFlow and PyTorch have vast ecosystem of tools, libraries, tutorials, and research papers. This community support can significantly speed up development and troubleshooting. Pre-trained models. Many frameworks provide access to pre-trained models. Example from TransFlow Hub or PyTorch Hub, enabling transfer learning which can save time and resources when working on similar tasks. Okay, now sixth point we shall see export to production. Once a model is trained, frameworks make it easier to deploy models into production environment. They offer tools to convert models into formats suitable for mobile devices, edge computing, or cloud-based platform, ensuring that the model can put to use in real-world applications. Integration with other technologies, frameworks also integrate with other platforms. TensorFlow and TensorFlow Lite. Okay, next slide we shall see. Okay, now the seventh point is what reproducibility and maintenance, version control and experiment tracking. Many deep learning frameworks allow you to save models, track experiments, and manage hypermeters, which is essential for reproducibility. This is particularly important in research and production environment where you need to document the results of the experiment or retain model based on new data. Cross-platform support. Most deep learning frameworks support multiple operating systems, Windows, Linux, Mac operating system, and hardware configuration ensures that the code can run on various devices. 8. 8 point better debugging and monitoring. Visualization tools, frameworks like TensorFlow and PyTorch often come with built-in tools for visualizing the model's architecture, training progress, and performance metrics. For instance, Transboard provide a comprehensive set of visualization for monitoring the model training in TensorFlow debugging features. Many deep learning frameworks provide better debugging tools that simply error tracking and troubleshooting, making it easier to issues in your code and model behavior. Okay, this is why we use the deep learning framework. The ninth point, that is maintainability and collaboration. Code modularity. Deep learning frameworks encourage writing modular code which make it easier to maintain and update. This is particularly important in collaborative environment which where multiple people might be working on different parts of the database code base. Standardization using the deep learning frameworks, standardization the development process, ensuring the consistency and easier collaboration among team working on the same project. Cross domain and versatility, wide range of application, deep learning frameworks support types of neural network, including conventional neural network, recurrent neural networks, RNN, transformers, and reinforcement learning models, making them applicable across domains like computer vision, natural language processing (NLP), robotics, and time series analysis. Interdisciplinary collaboration. These frameworks often allow easy integration with other fields such as reinforcement learning, computer vision, and speech recognition, making it simpler for teams from different disciplines project. This is why we use the deep learning frameworks. Okay, now choosing the right framework. Choosing the right deep learning framework depends on several factors, including your specific use case, team expertise, and the trade-off between the flexibility, speed, and scalability. Here is a breakdown by key factors to consider when selecting the most suitable framework for your project. Project requirement, task type, TensorFlow, PyTorch, scalability. Okay, this is the project requirement. The second point is what? Ease of use. Beginners friendly if you are new to deep learning or want to simpler framework to get started. Choose a high level framework with a simple API and good documentation. Keras, now integrated with TensorFlow, is ideal for beginners due to its straightforward APIs for building the models quickly. PyTorch also provides a relatively intuitive and flexible interface. Dynamic nature might require more familiarities. Okay, choosing the right framework, customization. If you need to the great control over the model architecture and training process, you might prefer a framework that allows more customization. PyTorch is known for its flexibility and dynamic computational graphs, making it suitable for experimentation. TensorFlow and Keras as a part of the TensorFlow often offers flexibility, especially with the custom layers and models, though it may require more. Okay, this one, right. Choosing the right framework. Now, third point, community and the ecosystems. It supports and documentation. A large active community and comprehensive documentation can significantly speed up development and troubleshooting. TensorFlow and PyTorch both have extensive documentation, tutorials, and large communities. However, TensorFlow has been around longer. Its community and ecosystem. Example: TensorFlow Hub, TensorFlow Lite, and more mature in certain areas. Keras has great community support as well as it's well documented for high level usage. Train models. Okay, this is community and the ecosystems. Fourth point, performance and speed. Training time, TensorFlow, PyTorch, MaxNet. So these are the points of the performance and speed. Fifth point is what deployment and production. Model deployment, TensorFlow, PyTorch, cross-platform support, TensorFlow, PyTorch. These are the points of the deployment and production, right? For example, the cross-platform support. If you need to deploy models across different platforms, example mobile, web, cloud, ensure the framework supports the necessary deployment targets. Then next point is 6 point, research versus production. Research, if you are in the research environment, you need flexibility and quick iteration. PyTorch is generally preferred due to the dynamic graph execution and ease prototyping. And second point is TensorFlow. So this is all about the research versus the production. 7 point, platform and ecosystem maturity. Maturity and stability, TensorFlow and PyTorch. For example, what is the maturity and stability? Consider the maturity of the framework in terms of updates, bug fixes, and long-term support. This is all the platform and the ecosystem maturity. Okay, this is the summary. Means at the end of the chapter, what we have learned is what deep learning frameworks make AI artificial intelligence development faster, scalable, and efficient. TensorFlow were the dominant, but other frameworks cater to specific needs. Choosing the right framework depends on ease of use, performance, and deployment requirement. Deep learning frameworks aim to make AI deployment faster, scalable, and accessible, ensuring efficient model training, deployment, and real-world applications. Deep learning frameworks offer a powerful combination of the ease of we use, flexibility, and efficiency by abstracting away complex operations, automating gradients calculations, optimization, computational resources, and providing a range of the additional tools. Okay, so this is the points we have learned in this lecture. Okay, now yeah, this is the end of the lecture. Thank you so much. I shall give you some questions like fill in the true or false, multiple choice question, and question answers at the end of this course. Thank you so much.